Okay. So, what we're going to go ahead to do today is we're going to do matrix multiplication. Okay. This is a little bit more of an involved process. Now, hopefully none of you had any issues with regular matrix addition, right? I mean, that should have been super easy. Basically, I think the only one anybody in my earlier classes had trouble with was number 11. And number 11 in the homework is just one that couldn't be done. And so the answer is can't be done. So that ended up being the only issue there. Matrix multiplication, okay?
Really hot in here today.
Yes, I know. Okay.
The
The sun came out, actually warmed up a bit.
stomach's wet.
Matrix multiplication, guys. Okay? Now, matrix multiplication is a little bit more involved than the addition and scalar multiplication was. Okay, and transposition. With matrix multiplication, it's got some special requirements, and the actual process is more formulaic than anything else. Okay, and we're going to go through all this today. The big thing about matrix multiplication, okay, is that the first condition is that our two basically they're order dependent. Okay, meaning that they lack the commutative property. Okay, so that is matrix A times matrix B does not necessarily equal matrix B times matrix A. Okay, so order dependent. There is no commutative property . So, in most cases, okay, matrix A times matrix B does not equal matrix B times matrix A. So that's a bit different than what we're used to, okay? And it's certainly different than addition, which was commutative all day long, okay? The second thing with them is the order property of matrices, that is how many rows and columns they have, is important to multiplication, okay? Just like, but here it's different. So if you remember with matrix addition, okay, you can add two matrices together if their orders are the same, that is, they have the same number of rows and the same number of columns. With this one, the condition's a little bit weirder, okay? Two matrices can be multiplied together if the number of columns in the first matrix is equal to the number of rows in the second matrix. Okay? So, what does that specifically mean? Okay? Basically, if I had a 3 by 2 matrix, okay, I can multiply that by any other 2 by anything matrix. Okay? It's just that my first matrix was 3 by 2, so any matrix I multiply that by has to have 2 rows, because my first matrix had 2 columns. Okay? That's the main condition with matrix multiplication. Okay? The product, though, that you get, your answer, is actually sort of the flip of this. Okay? So the number of your product will have the number of rows of the first matrix and the number of columns of the second. Okay.
Scroll up.
Yeah. Scroll up. You said right there.
Yeah.
All right. I'll go ahead and add this note here. So basically, and this is more of just a way to help you check yourself, but the product okay has the same number of rows as the first matrix, and the same number of columns as the second matrix. Okay, so matrix, if matrix A was m by n, and B is n by p, then AB is equal to m is n by p. Okay. Any questions there? They can be multiplied together because number of columns matches number of rows, and the product has number of rows of the first, number of columns of the second. Okay. The main important thing to remember is that basically the columns of the first match the rows of the second. This will fall away naturally. Okay, so when you actually do the multiplication, it'll always just end up being the way of this property down here. Okay, so this is the one to try to remember. Okay, any questions? I'll let you guys copy. Do I need to clean up anything? Explain it Word.
A is, that is.
Oh yeah, hang on, let me rewrite that down there. Okay, just make it clear. Okay. So, example, matrix A is an m by n matrix, B is n by p, so A times B is a m by p matrix. Okay?
That's an N, not, okay, N.
Yeah.
N times N.
M, the letter M as in Michael, times N as in Newt.
Big Newtons.
As big Newtons, yes, except without the big part. That begins with N. Okay. All right. All good with this so far? Okay, move to the next new page.
One sec.
Okay. Ooh!
What?
Oh, I stretched my neck to pop one of the, I guess, vertebrae. I'll sometimes do that.
That was good though.
I can't crack my neck. I don't know how people do it.
Yeah, it's one of those things like once you start cracking a bone,
Yeah.
you could generally crack it. So I could crack like all my fingers. I'm usually, and you're not supposed to do it because it's horrible for you apparently. But I can't help it.
It doesn't have anything that wrong.
like the thing I've heard multiple reasons why. I think the best one, the one that at least makes most sense to me and why it's bad, is that your joints, all your knuckles and things, are surrounded by like a little bit of fluid, and the sound that makes when you crack a joint is that fluid basically being popped out of place. And so the idea is if you do that too much, too often, basically it causes arthritis because the fluid then gets out of all misshapen and it starts to also solidify. And then eventually there's no more fluid basically around your joints, and so that's when arthritis forms, when bone starts grinding into bone. Now whether that's true or not is beyond me, but that's the explanation I've heard of why it's bad. I think it's just because it annoys people.
Yeah, people say that because they didn't know about it.
Alright, okay, moving on, now that everyone's got this copied down. Okay? Let's actually look at an example. We'll do one symbolically, and then we'll actually do one with numbers, of matrix multiplication. Okay? So, okay. The key with matrix multiplication is to remember, it's basically you're going to multiply a row by a column, okay? So you're basically multiplying rows by columns, and there's a specific way you do this. So if I wrote out two matrices here, okay, we'll call this one A, B, C, D, if I multiply that by matrix F, G, H, I, J, K, L, okay? Alright, I can multiply these matrices because this one has 3 columns and this one has 3 rows, so everything lines up, okay? Basically how it works is, I'm going to start with my first column, my first row here, multiply it by the numbers in the first column to get my first number in my new matrix, okay? Then I'm going to repeat that process. Multiply, use first row, multiply by second column to get my second number in my new matrix, okay? When I run out of columns, I switch to the next row, okay? So after that, second row, first column, second row, second column, and that fills in the rest of the matrix, okay? My product here is going to be a 2 by 2 matrix, okay? 2 rows, 2 columns, so this should be 2 by 2. Alright, so what this looks like, it'd be A times G plus B times I plus C times K. Okay? And that gives me the first number in the first row of my new matrix. Okay? Now, for the second number, I do the same exact process, but use the second column this time. So it'd be A times H plus B times J, okay, plus C times L. Okay? Alright? What's with the giggling? I think I have a good idea of what you're doing. It's alright. It happens. Okay? Alright. Yes. Okay. Now, we're out of columns, so we'll repeat the same process, but use our second row this time. So it'll be D times G, E times I, F times K. Okay? Then, finish it out the same way. D times H, E times J, F times L. Okay? And that is our product. Okay? Through the matrix multiplication. If you do every multiplication like this, you'll always end up having the right answer. Okay? So that's why I'm saying it's kind of multiply a row by a column. First row, first column, first number. First row, second column, second number. Okay? And you do that for all the columns until you're out of columns. Then you switch to second row, first column, number down there. Second row, second column, number down there. And you would do that for all of those. Ooh. Why did I say what was I looking up there? I won't. Any questions? Now let's actually look at it with real numbers here. Okay? And we'll do a big matrix. Okay? On the same page. Okay? So, we'll make this 2, 5, 8, 7, 9, 1. Okay? 2 columns. So I'm going to need this next matrix to have 2 rows. So it will be 5, 7, 8, 2, 6, 0, 1, 4. Okay? What's the result going to be? Well, again, row times column. So it'll be 2 times 5, 10, plus 5 times 6, which is 30. Okay? Then 2 times 7, which is 14, plus 5 times 0, which is 0. Then 2 times 8, which is 16, plus 5 times 1, which is 5. Okay? And then lastly, 2 times 2, which is 4. Okay? And 5 times 4, which is 20. Okay? So, my first row fills out like that. Okay? First row, first column, first number. First row, second column, second number. First row, third column, third number. First row, final column, final number. Okay? I'm out of columns, so now I'm just going to repeat the same process, moving on to my second row. Okay? So it'll be 8 times 5, which is 40, plus 7 times 6, which is 42. Okay, then 8 times 7, which is what, 56, plus 7 times 0, which is 0. Okay, then 8 times 8, which is 64, 7 times 1, which is 7, 8 times 2, which is 16, 7 times 4, which is 28. Okay, out of columns, move to the next row, repeat. 9 times 5 is 45. 1 times 6 is 6. So it would be 45 plus 6. Then 9 times 7 is 63. Plus 1 times 0, which is 0. Okay. Then 9 times 8, which is 72. Plus 1 times 1, which is 1. And finally, 9 times 2, which is 18. And then 1 times 4, which is 4. Okay? So that's what we get so far. Now, sorry, I'll bring it back up.
Yeah, you got done the second.
Okay. Now, to write out my final answer, I would just add all those numbers together. So my final matrix will be 40, 14, 21, 24, then 82, 56, what is that, 73, and then for 44,
71.
that was 71, yes, you're right. Thank you. And then 51, 63, 73, 22. Okay. And so that would be my final product. Okay?
Wait, how'd you get 40?
40,
42, because I thought you moved over to 7 and 0 on the second row.
second
So
row.
the product.
This one right here?
Yeah.
Okay. 8 times 5 is 40. 7 times 6 is 42. Okay. Then 8 times 7 is 56. 7 times 0 is 0. 8 times 8 is 64.
Oh, yeah, okay.
7 times 1 is 7. So on and so forth. Does that make sense now? Yes, Rhodes.
Where'd the 30, 10 plus 30, like the first thing, where'd that 30 come
5
from?
times 6.
Yeah. 2 times 5 is 10. 5 times 6 is the 30. Okay? Yeah, so what you're doing basically is as you move across the row, you move down the column. Okay? And adding the results together. Okay? So, basically first number times first number of the row times first number of the column, plus second number of the row times second number of the column, plus third row of the number times third number of the column, so on and so forth, on your way down. Okay? And that's how we end up filling out the matrix this way. Okay? Any questions? All right. I'm gonna have you guys practice this at your seats. Okay, and then have a volunteer come up on the board and do one of these. But before I do that, though, let's take a break and let's take a look at two special matrices and their products. Okay, so kind of special cases here. Everyone got this down now? All right, I'll wait. Oh, it's an iPad case. That's a nice iPad case.
Thank you.
It's better than my iPad case.
Are you gonna get the iWatch?
No.
The
There's
iWatch
no way
is so
Brendan is
dope.
gonna watch these videos.
Actually, he already has.
Oh.
I post them on YouTube and I can actually see.
Wait, if I looked them up right now?
Yeah.
What do they call it?
I usually call him class and then whatever the day is. And then I have a channel set up that he's the only subscriber to.
What's the
And
channel?
they're public.
What's the channel called?
That's just my name.
So I can just like sleep in a couple days and
Nah.
You mean next Khan Academy?
Am I going to be the next Khan Academy? Probably not.
That would be awesome if teachers filmed all their classes. So
That's kind of a pain in the butt, actually.
but if we had like a thing.
Yeah, I guess if there's a proper camera. It's really just this.
I found that
we no longer need to go to class.
watch these YouTube videos and not come to class.
No, gotta come to class still.
I hate
Oh,
biology.
this video.
Alright, but if you want to watch them before a test or something review, be my guest. Okay? They're there. Alright, moving on. Okay, so special cases, everybody.
Old daddy.
Okay, please turn me off. Okay? And pay attention to the me of now, not the me of yesterday. Okay, or Friday. or Thursday, or whenever it was first
It's
recorded.
Friday.
Special cases, that's because I have to break them up. It won't let me upload more than 15 minutes at a time, because life has to be different.
Is Maggie in?
Okay, so, special cases,
Yeah.
okay?
Here's Maggie in.
Basically, the first special case is with the zero matrix, everybody. Guys in the back, okay? A matrix A times the zero matrix is, of course, equal to the zero matrix. Okay? Alright? But there's a note here. Note. The rules about order still apply. Okay? So I can't just use any random zero matrix. I have to use a zero matrix that would work with matrix A. So matrix A has 2 columns. Okay? The zero matrix I use has to have 2 rows. Okay? But other than that, the result ends up being the same. Any questions there? Alright. The next one, okay? There's a special matrix called the identity matrix. We saw that last week. But basically, A multiplied by the identity matrix gives me the original matrix back again, A. You alright, Patrick?
Yeah.
Don't make it?
I'm gonna make it.
Alright. And again, same rules apply.
What is it?
Okay? So, I can't just multiply any identity matrix by A. I can only multiply the identity matrix that works with matrix A in this case. So if A was 5 by 2, I'd have to choose the 2 by 2 identity matrix. If A was, 4 by 7, I'd have to choose the 7 by 7 identity matrix. We're doing this multiplication. Let's take a look at an example of that one, because that one's a good one to see actually worked out. Okay, do I need to scroll back up?
Yeah, sorry, I didn't think it's
Woo!
stumble behind.
Guys are slow at the copying today.
Get a new piece of paper.
Had to like write the title, the date, my name.
It's not me. Tommy's just distracting us. Freaking out.
Tommy keeps telling me that it's
Still got a shit watch the YouTube video.
Alright. Be neat next year. I'll have maybe I can request a video camera in my
I'm so confused.
Probably could.
Plenty of room for you
Yeah.
in that.
I mean, I know the publication is trying to like snag their own rooms in there too.
I don't think that's.
You know what's gonna happen?
No,
I hope it happens.
Wait, you think?
I know for reason. I know right now the spare rooms that are in that new building are dedicated as overflow office space when they start the Walker Building renovations. So.
You're good.
Basically, it's going to be a while before they're free. And one of the ideas, now this hasn't been set in stone, but one of the ideas with the Walker Building renovation is to put things like publications, yearbook, that sort of stuff in there, in the newly restored
The furniture has
building.
like a sweet setup in the art studio, but like
We're in a closet. It's a
That's not a
glorified room
closet.
closet.
that is not. At least it's a special room you can go to like during the day. Like the Oracle in the town, like there's classes going on there to be like the one awkward person to be in there sitting in the back. Like, it's so.
No, but what are they gonna do with this floor? Because a lot of these rooms are like math teachers.
I don't know. I think, well, right now, a few rooms have been doubled up, so they'll undouble them.
Like 3
Wait, so
people
some-
in my classroom right there, like Mr. Heil, Ms.
Yeah.
Hemming, and Dr. Hall.
Yeah, so they can be spread
And
down
after
here.
too, for-
And I know there's other locations in the building where they're doubled up, so these will get spread out somewhere.
Psychology next year.
Alright,
Wait, what are they? Why are they?
so look at an example of this.
Wait, where are they renovating the walls?
They're hoping to start next year.
Like the whole thing.
They're redoing the whole thing.
They have to. The
How-
building is like falling down.
How are people gonna live in there?
They're gonna do it a section at a time. They're not doing it all at once.
You can make it infirmary, like the infirmary.
They are, one idea was to make the freshman classes slightly smaller. Another idea too, and a lot of these ideas are in like woodwork, so it's gonna be a long time before, and if they even get adopted. Another idea is to move over to a house system. A house system, so like, instead of like everyone, so like right now, like, all the sophomores are in Walker. All the freshmen are in like Taylor, etc.
So they mix
Um,
them.
it's-
Loud Finch, bro.
Dead turn it into like a house system, so you have kind of like in like Hogwarts, you know, like Gryffindor and Slytherin and
That'd be
Hufflepuff and Ravenclaw, kind of like that. Okay, and have you all like big stuff.
That would be terrible.
Well, it's so that way there's benefits to it. Other schools do it for certain, and it works great.
You know,
A lot
they
of
made.
colleges are trying to work that. Like when I went to California, like at least
Through enough
like
Xbox
3 of
teachers
out of
to
the
break
5
the
I people
foundations
like
to
had
show
were
that.
implemented ours.
Right. Okay. Let's look at the. Let's look at how this.
They'd be called Slytherin and
No, they wouldn't be called that. Let's look at how this identity matrix works when you multiply. Guys, pay attention.
Too bad I was
Okay.
fire.
So-
Sucky.
Hey, wow.
So this has 2 columns. So I have to, if I'm multiplying it by identity matrix, I have to multiply it by the 2 by 2 identity matrix. Okay. So 1 0 0 1. Okay. Again, works just like every other multiplication works. I do 2 times 1 plus 5 times 0. Okay. Then 2 times 0 plus 5 times 1. Okay. Move on. 7 times 1 plus 1 times 0. Okay. 7 times 0 plus 1 times 1. Okay. Then 0 times 1 plus 8 times 0. And then finally 0 times 0 plus 8 times 1. Oops. Okay. Working that all out. Okay. What does this come out to be? 2, 5, 7, 1, 0, 8. What I started with exactly. Okay. So that's basically the identity matrix. Okay. It totally works. Always gives you back what you started with. Okay. By the way, typically speaking, there are very few matrices which are commutative. The identity matrix is one of the few that will act that way when the conditions are right. So if I multiply a square matrix by the identity matrix for it, it always comes out. It's always a commutative exercise. Okay. So in that case, if A is 3 by 3 and I multiply it by the 3 by 3 identity matrix, A times I is equal to I times A, which is equal to A. Okay? So it actually works out that way. One of the cases. Okay? Alright. Good. Any questions about this right here?
Hold on a second.
Okay. Because I'm going to now give you guys 2 problems to work on your seats and then volunteer. Yeah, they'll just be pretty straightforward. Okay.
Let's do it.
This is confusing.
Wait.
Alright, got it?
Hold on.
Alright. So, kind of on your own now. I want you to work these 2 right here. The first one, we'll do, okay? That's the first one I want you to work. Then I also want you guys to try the second one. Alright. Go ahead and take a minute or 2 to work those out. Okay?
Give me printer paper that I can just.
Yeah, got tons of it. Right there.
Oh, and you nab me one of those.
Give me a Scoopy one.
Yeah.
Is that 540, the second line?
I
Yep.
appreciate that, Scoop.
540.
Area code here.
It is area code here.
Oh, I love this.
540.
540.
What's your phone's area, or what's your phone's area code? Is it 540?
It's 540.
That's a weird question, guys.
Well, I understand why it's a question. It
I was
says with
wondering
cell
if you got your
phones.
phone here or if you.
I got my phone here in Virginia like ages ago.
What's Athens area code?
706.
Jack, what's
Do you
yours?
miss
434?
Athens?
Sometimes.
You wish you could.
It's a good place.
It's a fun place.
I could look it up.
It's a fun place for people who are unattached and want to just basically have fun. If you have kids, it's probably not a very good place.
Well, you don't have kids.
I don't have kids, but I'm going to soon, so.
How many months?
In September, so I guess that's 6 months from now.
That's awesome.
That's an alright birthday.
September, maybe as late as October, it's like September 27th. So,
December's the best
it could
month
be
ever.
the week before that or the week after that. Or, you know, who knows, I mean, it's complicated. Let's say, I hope it's within the 2-week period around September 27th. Because then it's born good and healthy and not be premature.
Wait, oh, okay.
I was hella premature.
So it could possibly be 30.
I was
That
3 months
explains
premature.
everything about it.
I was, my brother and I both weighed like.
Could also be November 18th.
My wife's cousin, her son was born like really premature too. So he's just only now. Alright,
I could have thrown like.
who likes to volunteer for the first one?
David said he will.
Yeah, I'll do it again.
Okay, come on up. You don't have to write out the whole thing, just your answer. Okay. Alright, everybody, focus. Yeah, should work. You
So
just
would
write
the
it.
answer be 2 by 3 or 3 by 2?
Huh? With the answer, what will it be?
2 by 2.
It should be a 2 by 2 matrix. Why 2 by 2? It's got 2 rows and there's 2 rows in the first one, 2 columns in the second one. Okay. All right.
I could be wrong.
Okay. So the 2 times 5, which is 10. 3 times 6, which is 18, and 7 times 2, which is 14. So 10 plus 18 plus 14 should be 42. Okay. Then 2 times 1, which is 2. 3 times 3, which is 9. 7 times 7, which is 49. Okay, that should be 59, not 60. Okay, no wait, no, I take it back. My bad. No, you're right. It is 60. I read that as a 1, not a 2. Okay, so that's 60. That's correct there. So yeah, it looks like you got it just fine. So I think so. 1 times 5 is 5. 8 times 6 is 48. 9 times 2 is 18. That should be 71. And then 1 times 1 is 1. 8 times 3 is 24. 9 times 7 is 63. That should turn out.
Wait, how did you get 42 right there? I'm
Okay.
confused on that.
It goes like this: 2 times 5,
Right.
3 times 6, 7 times 2. So that would be 10 plus 18 plus 14. Okay,
Mhm.
that's going to be 42. Okay,
Okay.
30 plus 12.
And then next you do 1 times 1.
To get 60 over here, you do 2 times 1, 3 times 3, 7 times 7. Okay, that's how that worked there. Okay? And so that's how you proceed through these things. Okay? And so the answer comes up to be right there. Alright. Good. Now, how about number 2? Who got the answer for number 2?
I was thinking about it, I got confused.
You got confused. Now, why would you get
Just give it a
confused?
try. Just give it a try.
I get like,
Oh, wait, what was that?
Not possible.
It's not possible. That's why you're going to get confused with it.
I'm pretty sure Pat.
Everybody.
First.
I can't do this one, can I?
No, not.
The number of columns over here does not line up with the number of rows in this one. Okay? If I tried to do this, 2 times 8, 16, 9 times 5, 45, plus, I'm missing something to multiply by the 7. Okay? So, I don't have enough columns in my first one in order to do it. So when that happens, you'll know when that happens because you'll basically hit a wall. You'll have stuff that needs to be multiplied, but nothing to multiply it by. And it's not a 0. It's like literally like, can't do. So the way to answer this, just, can't be done. Or as one person did earlier, no. Just big no. Alright, everybody. Tomorrow, make sure you have your calculators with you, because we're going to look at how to use calculators to solve this. Okay?
All right, y'all have a good day.